Hello, ladies and gentlemen. Today we're going to talk about similar right triangles and when we can see three in a picture, how we might use that to help us solve. You're going to need something to write with. You might want 3 markers or different colored pencils, and you're probably going to want a calculator. So let's get started. All right, so just as a breakdown or a review of our parts of a right triangle, we need to remember that in order to have a right triangle, again, we need to have that 90-degree angle in the corner. Once I know that that 90-degree angle is there, I know that the side across from that 90-degree angle is my hypotenuse. And from there, then we have 2 different other sides. So we call these legs in a right triangle. And now as we go forward, we're going to want to kind of look at them and, okay, what's the difference in my legs? Well, looks like one might be shorter, so we might call that my short leg. And the other side we're going to call my long leg. Now this is important as we go through today's lesson because we're going to want to compare short legs to short legs and long legs to long legs and vice versa, because again, since we're dealing with similarity, remember similarity is always that comparison. So let's jump forward and see what happens. All right, in this first example, again, we're going to want to use similar triangles to help us solve here. So if we look at this big triangle as a whole, I hope that you can see the 3 right triangles within the whole triangle. So when we break that down, the goal is to outline those 3 different triangles and see if we can label them on their own. So I'm going to draw them separately and then label them on their own. So in this small triangle, what I know is it looks like I know the short leg is 7. I don't know the long leg and I also don't know the hypotenuse. Okay, so then let's look at the next triangle we have, which is our medium-sized triangle. And if I just manipulate that medium-sized triangle and turn it to look like my smaller triangle, I could then maybe compare them because again, they're both right triangles. So then on that smaller triangle, we want to compare what we know on the smaller triangle, and it looks like I don't know my short leg on that medium triangle. I do know my long leg on that medium triangle, and I don't know the hypotenuse, but it is labeled for me as X. The last one then we're going to want to draw is our whole triangle. So if we draw that whole triangle out over here, sorry for the poor drawing, but you get the idea. So if we draw that whole triangle out here, it looks like, again, I don't know my short leg. My long leg isn't known, but it is labeled as X. And then the whole hypotenuse looks like it's going to be 7 and 17, which would give me 24. So now when I look at these 3 triangles, my goal or my objective then is to compare 2 triangles that might have similar labels. Now if we were to compare the small and the medium triangle, we couldn't do so because the medium triangle doesn't have a short side. Likewise, the small triangle doesn't have a hypotenuse or a long leg labeled, so those 2 aren't going to work. But then if I look at comparing my medium and my large, if you notice, it looks like the medium triangle has its hypotenuse and long leg labeled, and the large triangle also has its hypotenuse and long leg labeled. So again, since we're comparing similar triangles, similar probably tells us that we're going to want to set up a proportion. Again, so if I compare hypotenuse to hypotenuse, hypotenuse in medium would be X, hypotenuse in large would be 24. Then I want to compare long leg in medium to long leg in large. And here now I just have a proportion. In order to solve this proportion, I just have to cross multiply. So I'm going to get x squared equals, now if I type in 24 times 17, I get back the number 408. Now to get x alone, again, we want to take the square root of both sides. X equals, if I type that in my calculator, I'd get a decimal. So this means I'm going to have to break that down into perfect squares that go into 408. When I did my math, I got 4 and 102. And if I do that math, then the 4 makes it go poof, turns into a 2, radical 102. So when I solve for x, this is what I got for x. Again, I don't want to leave it as a decimal. I want to simplify that radical. All right, so let's look at example 2. Again, we're going to want to compare the 3 triangles we see here. So let's start by drawing our small triangle and labeling what we know. It looks like in that small triangle I know 6, and 6 would be the short leg of my small triangle, and I know x, which would be the hypotenuse of my small triangle. Then I want to go on to my medium-sized triangle. It looks like I don't know the short leg on my medium-sized triangle. I do know the long leg, and I don't know the hypotenuse. So then I go on to my large triangle, and here it looks like, again, I know the short leg of my large triangle. I don't know the long leg, but I do know the hypotenuse. If I would add the 6 and the 14 together, I would get 20. So now, if we compare the three triangles that we've drawn out, it looks like we want to compare the small triangle and the large triangle since they have sides that compare to each other, and the medium-sized triangle has nothing in comparison to my small or my large. So again, since we're comparing, that means we want to set up a proportion. So if I compare the hypotenuse on my small triangle to the hypotenuse on my large triangle, and I compare the short leg on my small triangle to the short leg on my large triangle, I've set up a proportion, and now I can cross multiply to solve. So I get x squared equals 120. If I take the square root of both sides, I get x equals, again, if I typed in the square root of 120 into my calculator, you'd get a decimal telling you to break down that radical. The largest radical, or the largest perfect square that I found to go into 120 was 4. So when I divided 120 by 4, I got 30. The 4 makes the radical go poof into a 2, and 30 stays as the square root of 30. So again, if at any point you're confused throughout this, make sure you jot down the questions on how I labeled my triangles, how I set up my three triangles, how I set up my proportion, how I solved my proportion. Make sure you jot those down so we can visit those when we return to class. All right, example 3 again. Let's set up our three different triangles. So the small triangle, it looks like I know that the short leg is 8 and the long leg is x. I don't know my hypotenuse. In the medium triangle, it looks like I know that my short leg is x, my long leg is 15, and I don't know my hypotenuse. And in the large triangle, I don't know short or long leg, but I do know that my hypotenuse would be 15 plus 8, so my hypotenuse would be 23. Now again, when I look at the triangles I want to compare triangles that have similar labels, and that looks to be my small and my medium. So when I set up my proportion to help me solve this, I'm going to take the short leg in the small over the short leg in the medium, and I want to take the long leg in the small compared to the long leg in the medium. So now again, we're just going to cross multiply. It looks like I get x squared equals 8 times 15 would be 120. Take the square root of both sides. I get x equals, now remember in our last example, example number 2, we did the square root of 120. And if you jump back and you look at your notes, it looks like the square root of 120 ends up simplifying to 2 square roots of 30. So we could cheat a little bit and use that from our last example to help us get to that answer of 2 square roots of 30. All right, number 4, our last example of the day then is an example where we need to find a couple different variables. So again, let's start no different than we started our last 3 examples. Let's draw the small triangle and label what we know. It looks like the short leg in our small triangle is going to be that A. It looks like the long leg is 10 and the hypotenuse is B. If we go over then to draw our medium-sized triangle, it looks like on our medium-sized triangle, our short leg is 10, our long leg is 24, and our hypotenuse is 26. And if we go over to our large triangle then, it looks like the short side on my large triangle is B, the long leg is 26. If you notice, to get the hypotenuse, I have to add 24 and A. So 24 plus A would be my hypotenuse of my large. So again, then you want to look at comparing two triangles that have similar labels. But if you notice in this example, all 3 triangles have every side labeled. So when I look at this, it looks like my medium, I have all known sides. All of my medium sides are numbers. So if I were to try and solve for A first, I would want to maybe do my small to my medium so that I could do A over 10 compared to 10 over 24. And the reason for doing this, because if I looked at my small triangle and my large triangle, we would compare A to B and I'd have 2 separate variables and that wouldn't help me. So again, in this example for A, I want to solve by comparing my small triangle and my medium triangle. So if I cross multiply this one then, I get 24A equals 100. If I were to solve for A, I would divide both sides by 24. Looks like A is going to equal 100 over 24. But this isn't my simplest form. So if I were to simplify, I could take out a 4 out of both of them. I take out a 4 out of 100, I'd get 25, and a 4 out of 24, I'd get 6. So A would be the value 25 over 6. So let's try solving for B then. Again, if I look at B, I could compare B in my small triangle and my medium triangle. Again, I want to use my small and my medium because in my medium, they're all labeled with numbers. And if I were to compare my small to my large, again, I'd be comparing to an A value and a B value. Would have two different variables, and that wouldn't be fun to solve. So let's do my hypotenuse in my small, which would be B, over my hypotenuse in my medium, which would be 26, compared to my long leg in my small triangle, which would be 10, over my long leg in my medium, which would be 24. So when I cross multiply, I get 24b equals 260. Again, divide both sides by 24. And to save some time, it doesn't divide out nicely, but if we were to simplify it, we could take out a 4 again in both. We'd get b equals 65 over 6. So again, if you have any questions throughout this whole video, make sure you jotted them down so that when we get to class and we visit one of these examples, you have specific questions to ask me and you don't get super confused when you are given the assignment. So I want to thank you for taking good notes, and I'll see you in class.